Wisconsin, I went to New York, my mathematics group there, and then statistical research group, and back to Wisconsin, and then here. And if you want to hear about the early part here, then you come to the Fall Technical Conference.
Yeah.
So is that numbers? One of the things that I learned when I was at SRG was.
I am Joan Rosenblatt. It is my privilege to introduce Churchill Eisenhart. Dr. Eisenhart established the Statistical Engineering Laboratory at the National Bureau of Standards in 1947 and served as its chief until 1963. He was then appointed a senior research fellow at the National Bureau of Standards. In that capacity, he has served as senior statistical advisor to the Bureau's management and to his followers in statistics, while also pursuing scholarly studies in the history of science. Dr. Eisenhart will talk this morning about some of his experiences as a participant in the development of the statistical theory and methods that have come to be standard practice in scientific laboratories. Churchill's talk is based on a lecture that he gave at the University of Connecticut, sponsored by the Pfizer Research Foundation.
Good morning, colleagues. I begin with my entering Princeton in the fall of 1930. As a freshman, I offered Latin for admission, and for that reason, my degree, even though it later was in mathematical physics, was nonetheless a Bachelor of Arts degree. That was the practice in Princeton in those days, if you offered Latin for admission. I took the usual courses when you become a freshman, you know, calculus and chemistry and physics and history and economics and that sort of thing. Some German, which in spite of my name, I barely kept my head above water in. And it wasn't until the spring of 1932, the second semester of my sophomore year, that I had a course that started me on my ultimate career. It was called Mathematics in the Natural Sciences. It was taught by Professor Howard Percy Robertson. We all called it Relativity and Poker, because the first part of the course we studied both the general and special theories of relativity from a book by L. Bolton that was published in 1921. And in the second half of the course we studied probability and its applications in engineering and the physical sciences, using as our text a book by T.C. Fry of the Bell Telephone Laboratories called Probability and Its Engineering Uses, which had been published in 1928. Apparently, I showed some interest in the probability part, and I had been taking some physics courses, and we had laboratories, you know, with the physics courses. And in the laboratory, we were expected to take several observations and calculate the arithmetic mean and calculate the probable error of our mean using the standard formulas of the day, as illustrated, for example, in a little book that was by a man named Weld called Probability Theory of Errors and Least Squares. And so that way I got some knowledge of the theory of errors. In my junior year, that was the 1932-33, there was to be a William Marshall Bullitt Prize in mathematics. This prize is offered annually for the best essay written by a member of the junior class on some topic related to his departmental reading. Since I have always liked mathematics for what you can do with it and not as for itself, and so I was sort of out of place in the mathematics department in Princeton, I did not intend to enter this contest, but it turned out that the man in charge of the students who were going to compete for this prize was Edward U. Condon, who at that time was assistant professor of physics at Princeton. And Condon came around to see me, and he says, "Robertson tells me that you're keen on probability and the theory of errors." And I said, "Well, I'm sort of interested in those. They seem to be useful." And he said, "Have a look at this book." And he gave me a book called Statistical Methods for Research Workers by R.A. Fisher. I think it was his copy of probably the second edition. And I looked at that book, and I came back to him and I said, "Professor Condon, if what this fellow says in this book is anywhere near correct, then all the people that I know in physics lab and so forth don't know how to analyze small sets of data." And he said, "What that man has written in that book is very sound. Go out and translate it." So that got me started. But then I had a bit of trouble because I couldn't fully understand this book. You know, it's a bit hard to read. As Morris Kendall once remarked, it's a book you never should read unless you had read it once before. And at this point I discovered that I had just made a good choice of father, because I was complaining about this at home one day, and my father, Luther Eisenhart, who at that time was the dean of the faculty and chairman of the mathematics department, said, "Oh, Fisher, there was a fellow with a lot of whiskers and sort of thick glasses that gave a talk up at the International Congress of Mathematicians in Toronto. And he said something about this talk he gave being the explanation for the book that he'd written, which a lot of reviewers seemed to feel the need for." And so he went over to his shelf and took out a great big blue book, which was the second volume of the proceedings of that conference. And sure enough, in there was Fisher's paper, "The Distribution Yielding the Error Function of Several Well-Known Statistics." Now that unfortunately was published in 1928, although the conference was in 1924. And at the end of it, Fisher has an addendum. "Since the International Congress of Mathematicians in 1924, the practical applications of the developments summarized in this paper have been more fully illustrated in the author's book, Statistical Methods for Research Workers, Oliver and Boyd, Edinburgh, 1925. The Toronto paper supplies an outline, the mathematical framework around which the book has been built, for a formal statement of which some reviewers would seem to have appreciated the need." But my father helped me further, because he was one of the editors of the Annals of Mathematics. And he said there was a fellow named Ryder who had an article in the Annals, notice Annals of Mathematics, not of Statistics, Annals of Mathematics, a few years ago, called The Theory of Small Samples. And he went to his files and dug that out. And I read that, and it was very, very helpful indeed. And this fellow Ryder really had his finger on Fisher, because in the introduction to that paper he remarks, "Undoubtedly the leading writer in the theory of small samples is R.A. Fisher, whose work in this field has revolutionized modern sampling theory. Much of it is to be found in his book, Statistical Methods for Research Workers, but this book is extremely unsatisfying to a mathematician, as it merely states results without proofs and usually without even indicating how a given result may be derived. It discusses such things as the distribution of T without telling what T is, what the distribution is. In his original papers are much more enlightening, but from the references as given in the book, it is sometimes difficult to tell which paper treats of which topic. Even these papers suffer in places from the same defects as the book, and they are often troublesome to follow." Well, Fisher must have forgiven Ryder if he ever read that, because when I got to London in 1935, I found Ryder sitting up on the top floor in Fisher's territory. Well, to make a long story short at this point, I wrote a paper on a discussion of students' method for testing the significance of a small number of observations. Now, when I look back and read it over today, I see it's not the sort of a paper that I would write if I was trying to introduce students' work to statisticians. This was really aimed at my physicist friends to point out to them that stress the fact that a standard deviation calculated from a small number of observations, the S calculated from a small number of observations, is a very poor measure of the standard deviation of the measurement process and can be off by 40 or 50% easily. And also that the distribution tends to be skewed so that it'll tend to be too small more often than too big. And so my point in writing that paper was to tell physicists that they had to put much wider uncertainties on their results. And with good luck, I managed to win the prize. Years later, when I got to be a good friend of a student in England and told him about this, he was delighted. He said, "Somebody's made money with my work. This is great." And he used to introduce me as the young man who had made a fortune. It was $100 using his work. In the summer of 1933, I found that I had made good choice of a roommate because that was Henry Norris Russell Jr., because his father was Henry Norris Russell, the Dean of American Astronomers, and an truly exceptional man. Nobody up to that time had ever, and probably since, has never gotten such high grades in every course he took at Princeton, with the result that when he graduated in the first year that Princeton was Princeton University rather than College of New Jersey, namely 1897, he was given the degree Sigma Cum Laude. That was even better than Summa. It was uniquely Cum Laude. Now, Professor Russell wrote a monthly column on astronomy in the Scientific American. And he came to me one day and he said, "Churchill, Robertson says you can write a bit, and the Scientific American needs somebody to answer a whole lot of letters and stuff that they get, correspondence that they get on scientific topics. Would you like to try your hand at it?" And I said, "Okay, I'll try my hand at it." And so I did. Now, one of the things that fascinated me with this job, and really I still don't understand it to this day, was the frequency with which I would receive from the Scientific American a letter that had been posted in Pakistan, Turkey, Greece, or some far-off place that had a problem in physics to which they would like a response. And it turned out, and this was the interesting part, that I was able to solve it very quickly because just a few days before, or maybe a week before, in my course in physics or math, I had just learned the mathematical tool or the physical theory that was necessary to solve it. And I often wondered what I'd have done if that letter had come sooner. I still don't know what I'd have done. It was remarkable. This happened very frequently. Now, much of the correspondence, of course, was from cranks who wanted to know all sorts of strange things like squaring the circle and trisecting the angle. And I got so tired of writing replies to how you can't trisect the angle if you follow the rules, but you can do it very easily if you break the rules, that I wrote an article called Trisecting the Impossible. Now, the Scientific American always edits what you write, and they give it a title. So I didn't give it that title, but that's what they gave it to me. That came out in 1936. Now, years later, when the Bureau's attorney was building me up as a great expert, in the battery additive hearings, he had me tell about my experiences, and I told about this years of being a contributing editor to the Scientific American, answering correspondence from people, mostly from cranks. At that point, the manufacturer jumped up and said, "Objection." And the hearing examiner said, "Mr. Ritchie, you cannot object. The witness is describing his experience." So I apparently had touched a sensitive chord. Another outgrowth of that contributing editor bit was that one day Professor Robertson came to me and said, "Churchill," he said, "Professor Einstein has been asked by the Scientific American to write an article on the present status of the ether. As you know, there are some people who feel that there's a sort of a medium in there, a sort of a fluid in there through which light waves wiggle, or through which particles come running like bullets in the corpuscular theory, and as you know, in the relativity theory, you don't have to have an ether at all. And Professor Einstein is not eager to get into this controversy in public in a popular magazine. And he asked whether, don't I have a student who could do it? And I said, yes, I have. So he said, you remember you wrote a paper on this in my course, so why don't you just dust it off and send it in? So I dusted it off and sent it in, and sure enough, it got published as The Ether Riddle of the Ages. Now let us move on to my senior year. You know, up to this point, I hadn't really had any formal statistics. And so in the first semester of my senior year, that's the fall of 1933, I had a course in elementary statistics taught in the Department of Economics and Social Institutions, that's important, by Professor J.G. Smith. The book we used was by Chaddock, published in 1925, called Principles and Method of Statistics. But the presentation of the course, while we used that as a text, was really more like Professor Smith's own book that came out the next year called Statistics and Introduction to the Principles of Scientific Methods. Now there was a laboratory with, you know, we have to have a laboratory in statistics course where you crank out lots of numbers and so forth. And the instructor in this laboratory was a graduate assistant by the name of Atchison J. Duncan. And we had tabular and graphical presentation, descriptive statistics, least squares fitting by Doolittle method, index numbers, moving averages, link relatives, and all that sort of stuff. And I can see why students of statistics don't like the subject, because that was a very dull part of the course. The next semester was a follow-up course by Duncan, who got his MA in 1927 and was at that time had been working on his doctoral dissertations for some time, called Modern Statistical Theory. And this was based upon the mimeograph chapters of Hotelling's never published Statistical Inference, and contributions of Student and Fisher occupied the center stage. Hotelling had been a student at Princeton in the early 20s. He was a J.S.K. Fellow in mathematics at Princeton, and his coming there was a bit of a joke on him. He came, I'm told by Alan Wallace, because he saw that Veblen was there, and he thought Thorstein Veblen was there. Instead, it was Oswald Veblen, the geometer. And but having gotten the fellowship, he stuck around for 2 years and got his PhD in mathematics in 1924, writing a thesis in something to do with differential geometry. I'm not sure whether it was while he was there that he, or whether after he'd gone to Stanford, that he wrote his famous paper, The Distribution of Correlation Ratios Calculated from Random Data, which was published in the Proceedings of the National Academy in October 1925. That was the paper in which he gave the distribution of what is essentially the F, it's F over 1 minus F, or the other way around, which actually hit the street before Fisher's derivation in the proceedings of that Toronto conference, which didn't come out until 28. And it also marked Hotelling as the leading exponent of Fisherian theory in the United States. Hotelling and his wife Floy had gone to England in 1929 to visit Fisher at Rothamsted with the intent of getting Fisher's cooperation in writing a textbook. Fisher was not interested. And shortly thereafter, Floy died, and Hotelling never did write a textbook. In addition to studying student Fisher theory in the Duncan's course, I remember we also got involved and fracas that was going on that time in the literature between Sewell Wright and a man named H.E. Niles. Sewell Wright was at Chicago, geneticist. I don't know where Niles was, on path coefficients. As I remember it at the time, my feeling about it was that these path coefficients were using correlation, multiple correlation coefficient showed the determination of the final result by all the things that came in front. And Wright had worked out a scheme whereby you could show the amount of determination that flowed down different arrows. And in Wright's case, this was fairly straightforward because your grandfather and your father certainly your grandfather you don't influence your grandfather's genetics or your father's genetics, so the arrows had a definite point to them. In the Niles applications, which led to some ridiculous results, it were in economics and some other areas, it wasn't entirely clear that the arrows were all, the lines were all single arrowed. You know, some of them might have had influence flowing both ways. And so I thought that was but the last word on the subject, I guess, are two papers by Wright, followed by one by Tukey, in a book called Statistics and Methods in Biology, which Ken Thorne and lots of other people edited, that came out by the Iowa State College Press in 1978. So if you really want to learn about path coefficients, that's the place to look. Now, I thought it remarkable when this course showed up, that this course showed up for the first time in the Princeton catalog just when I needed it. I discovered later that my being there to take it was a coincidence, that this course had been in gestation for several years. In the current issue of Statistical Science, I haven't looked at it today, there's some remark in there by John Tukey in which he says that statistics never would have been born at Princeton if it hadn't been for Luther Fehler Eisenhart, or something to that effect. I believe this to be correct. But the influence of Harold Hotelling must also be recognized. Without Hotelling's repeated prodding, my father might not have acted as forcefully as he did. Hotelling kept sending to my father his various publications in statistics from 1924 on, and especially his negative reviews, his devastating reviews of American books on statistics. For example, one by Edmund Day that was published in 1926, and his explanatory article, British Statistics and British Statisticians Today, that appeared in JASA in 1930, and recent improvements in statistical inference that appeared in JASA in 1931. So Hotelling kept poking at my father about here was an important new field. My father was somewhat handicapped by the flavor of the Princeton Mathematics Department, which for 40 years had been a leader in geometry and algebra, and with the coming at that particular point of the Institute for Advanced Study, which was housed in the same building. Mathematical physics was the thing. Einstein was there, Weil was there, Banana was there already, Wigner was there. The climate didn't look very good for statistics as a diversion at that point. The event that was instrumental in forcing the issue had been the arrival of Charles F. Roos as a National Research Fellow in Mathematics in the year 1927-28. Roos had received his PhD in theoretical economics at Rice Institute in Texas under Professor G.C. Evans, who at that time was developing a new mathematical theory of economic phenomena termed economic dynamics, and had then spent 1926-27 at the University of Chicago working with Professor Henry Schultz, who at that time was deeply engaged in his epochal research on statistical laws of supply and demand. While Roos was at Princeton, he persuaded he'd come there to broaden his mathematics so he could do some of this kind of economic dynamics. But while he was there, he persuaded some members of the Department of Economics and Social Institutions that they were going to fall behind if they didn't have some of this new kind of mathematical economics in their program. Now, the difficulty was that the Depression was on. By the time that this really got going, 1928, 29, and 30 and 32 and so forth, and the Department of Economics didn't quite see how they could offer this. In the first place, it was going to be hard to find an instructor. Secondly, they didn't have any money to pay him with. So the solution was that Professor Graham, the chairman of the department, approached my father in his capacity as dean of the faculty and chairman of the research committee and suggested that one way to overcome this lack of competence would be to send one of the young instructors in the department to study with Professor Schultz at the University of Chicago. My father was favorable to this proposition, subject to one additional provision. The individual who studied with Professor Schultz should also study the modern theory of statistical inference with Harold Hotelling at Stanford University for the purpose of initiating a course on this subject on his return. The victim was Atchison J. Duncan. And this is how it came to pass that Duncan, with the assistance from the International Finance section of Princeton, spent the first half of the academic year 1931-32 studying with Henry Schultz at the University of Chicago, and the second half with Professor Hotelling at Columbia. Atch lost out there. He had looked forward to a nice trip to the West Coast, but in the meanwhile, Hotelling had moved from Stanford to Columbia. This was very disruptive to poor old Atch, because he had been already on work on his doctoral dissertation in South African gold and international trade, and his studying for and presentation of this course held that up until 1936. So it's, as you can see, the course had been in the oven for some time before I got there, and my being there was just lucky. Wilkes arrived in Princeton in September 1933 to enter on duty as an instructor in the Department of Mathematics, an appointment that my father had offered to him in May 1933 when I was winding up my Bullitt Prize essay and before I had decided to pursue further study in statistics. Of course, when Wilkes arrived, I thought that he'd been hired to teach me. But that wasn't the case at all. What happened was that Wilkes was in England as a international research fellow, and he had spent 1 year, half of 1 year, no, 1 year, I guess, with Egon Pearson at University College, and the two of them wrote some papers together. And then he spent the next time at Cambridge with Wishart, and he now was finishing up, and he was in trouble. He had a wife, had a new child, Stanley, had no job. He wrote back to the United States, to University of Iowa in Iowa City, where he had gotten his PhD, and Reitz said, "Love to have you, you're one of my best students, no money." He applied to Hotelling, same problem. I'm just starting up this program in the Department of Economics, no money. He'd studied with Hotelling en route from Iowa to London. He applied to Egon Pearson. Pearson said, have no vacancies. Bartlett has just joined us here for a while, and I have no vacancies. So Wilkes was desperate. And Hotelling pressured my father, and my father succumbed, and hired Wilkes over the opposition of the entire Department of Mathematics. You see, he had all the cards in his hand. He was the chairman of the department, the dean of the faculty, and the head of the research committee. Who was going to fight against this guy? So Wilkes came there, but and his first year, first 3 years more or less, he spent teaching the usual courses in analytic geometry, calculus, and so forth, and in his spare time doing further research in multivariate analysis, and also working with the College Entrance Examination Board. When Dad had offered him this position, he had offered him a double position as instructor in mathematics and as a part-time employee of the College Entrance Examination Board. That goes back to about 1924 again. I don't remember the exact year, but somewhere around about 1924, there had been a fracas about whether the College Entrance Examination Board's methods of grading were reliable. And a committee was appointed, which my father was a member, and H.L. Reitz and Craythorne, and I don't remember who else were on that committee. And so Dad got to see about the College Entrance Examination Board and became a friend of Carl Brigham, who was the head of it, and became aware of through Brigham of their need for somebody to handle multivariate analysis, and there just wasn't anybody in Princeton at that time. So when Dad offered Wilkes this job, he offered two jobs, teaching in the math and this job with the College Board. Now, he didn't get to teach. He didn't get to teach until 1936. Now, I felt it necessary to give this explanation because, as you can appreciate from what I've said already, that Professor Carver was not really correct when he had an article in the Annals of Mathematical Statistics in which he said, one day I asked Wilkes how it was that he was not teaching a course in mathematical statistics at Princeton. He replied that he had tried to start such a course, but his superior turned down his request each time, probably because mathematical statistics and probability had not yet rung a bell in the state Eastern colleges. As you can see, it had rung a bell, but there was a problem. At the time that Wilkes arrived, as in many places, statistics was the province of the Department of Economics and Social Institutions. And there's the second thing was that if Wilkes were to have a new course, this would be a new course in the curriculum. And as I said, the Depression was just being come out of, and the study committee of the faculty was not eager to start new courses. And a third difficulty was that Wilkes at this point was only an instructor. And in a department of such great international distinction as the Department of Mathematics, it would be unthinkable to have an instructor in charge of a course. And finally there was that inhibiting factor that I mentioned before about the emphasis being on geometry and mathematical physics. But by 1936, the thing had been arranged, and economics was told that they could teach courses with applications in economics, but the basic course would be taught in Department of Mathematics by Wilkes. I don't know how much of the delay was caused by the fact that my father lost his club in 1933. In 1933, in the summer of 1933, he ceased being dean of the faculty and became dean of the graduate school. And so he no longer was in charge of the undergraduate curriculum. That may have had some influence, I don't know. That may have taken him longer to twist people's arms. Well, Wilkes helped me do my undergraduate thesis which was the accuracy of computations involving quantities known only to a given degree of approximation. And most of that had to do with the sort of thing that with rounded numbers and and how to what's the error in the final thing if it's a product of things of all sorts of different number of decimal places. But there was also a section in there on the statistical aspects for measured values. In the summer of 1934, I worked for the College Entrance Examination Board at its Princeton headquarters. They had a lot of statistical work there. They would test the validity, so what they called, I guess, the validity of questions by finding out how the responses of the students to question 17 correlated with the responses of the same students to the totality of all the other questions. And also I worked on there was a Swedish man whose name I think was Paulson, who had devised a test that was supposed to discriminate between the different kind of artists, freehand drawing artists, commercial artists, and people who could design wallpaper and carpets. And this test seemed to really do that to some extent. The thing that I was working on, along with some others, was the extent to which some of the questions were gradable, in the sense that we had the students, these things were given to students at Pratt Institute in Brooklyn, and then a whole lot of experts, presumably, were asked to grade them. Now some of the questions apparently were ungradable, in the sense that that 5 experts couldn't agree on whether that guy should get an A or an F on this particular response. You see, there also was a rather funny case in the regular questions. There was a question on there on the English exam in which the correlation was highly negative. The students who did well on the rest of the exam got the wrong answer on this one. And on looking at it, you had to decide that the good students knew they were good students and they could afford to be wrong once just to have some fun. The question involved 4 words: increment, decrement, excrement, sacrament. And you were supposed to underline the 2 words that were opposites. And the correct answer was supposed to be increment and decrement. The best students underlined excrement and sacrament. Wilkes also helped me with my first 2 statistical publications. The first appeared in the American Journal of Science, and it was called A Note on a Statistical Method for Comparison of Heavy Mineral Sweets, which appeared in that journal in December 1935. In May 1935, there had appeared a paper in there by a professor at Bryn Mawr, which was called A Statistical Method of Comparison of Heavy Mineral Sweets. And the idea there was that you have a bed of gravel here and you have another bed of gravel over there, and so you take some stones from each, and now you look at these and write down what the various minerals are in the ones here, and you write down what the minerals are in the ones there, and then you want to get a measure of how closely associated these are. Are they very alike or are they not alike? And unfortunately, this man had used a measure of association that, as I showed in my note, was language dependent. If you did his in German or French, you got a different answer than if you did it in English. And so I proposed that you use the chi-squared method, which did not depend on language. And that was what my proposal was. And then I wrote up the chi-squared method for geologists in another one called A Test for the Significance of Lithological Variations, which was published in the Journal of Sedimentary Petrology at the same time, December 1935. This apparently was these 2 papers were the introduction to geologists of the chi-squared method, because the paper, the Sedimentary Petrology one, was reprinted in a book on benchmark papers in geology that appeared 1985 or some time like that. There's a copy in the Stat Lab. However, it turns out that my solution wasn't the right one either, because it turns out that if you use the chi-square distribution in this test, everything turns out to be significant. You take a handful of gravel an inch away from another one, and it's different. And the proper solution was ultimately proposed by my friend Bill Crumbine. You have to do an analysis of variance. You have to multivariate analysis of variance. You have to take several samples from this and several samples from that and find out whether these two things agree or disagree more than just samples from the same place. And so the solution I gave for the problem wasn't the right solution, but now one other thing happened that turned out to be somewhat abortive at that time, probably with Condon's influence. I was asked to cooperate with Mr. J.L. Barnes, who was then a professor at MIT, on a section on the precision of measurements in Eschbach's Handbook of Engineering Fundamentals, which came out in 1936. So I got this opportunity to write this little section on precision of measurements, and with guidance from Wilkes, I wrote a little section that was sort of a hybrid between appropriate portions of statistical methods by Fisher and the 1933 ASTM Manual on Presentation of Data. Sent this off. Well, it got to the editor, and the editor looked at this thing and said, "My goodness, this thing is nothing like the sort of sections we've had on this in the past. This is too far out." And so Barnes took over, and the first part of this thing is all the old stuff, probable errors and all that razzmatazz, and all I got kept in that I wrote was the part pointing out how very uncertain the standard deviation is calculated from a sample. So that didn't work out. Apparently you have to proceed gently. If you proceed too hard, you get to have the door slammed in your face. Well, in the fall of 1935, I'm now going to London. I became a PhD candidate in the Department of Statistics, University College, University of London. My choice of going there, I suppose hoteling would probably have had me go with Fisher, but Wilkes, his influence had me go to Pearson, which actually, since I had never had any biology, was probably a good idea anyway. And also I had been sort of interested in the sort of things Pearson had been doing, because I discovered that through Fry's influence, Fry or Schuhart had been peppering Dad with Schuhart's publications, so I had a nice stack of those that I had fished out of my father's reprint file. So I went off to the University of London. Now I want to back up just a little bit to remind you that the great Carl Pearson, who was really sort of the founder of statistics as a science, had retired in the summer of '33, and he had been Galton Professor of Eugenics since 1911, and the head of the Department of Applied Statistics also since 1911. That department had been a blend of a previous thing that he and Weldon had, which was called Biometry Lab or something of that sort. And he was the editor of Biometrica. He'd been that since he was the founding editor in 1901, and he was the editor of the Annals of Eugenics, which he founded in 1925. Well, with Pearson's retirement, the University of London hit the old boy below the belt. They appointed his biggest enemy, R.A. Fisher, as Galton Professor of Eugenics, and split up the department into the Galton Laboratory of National Eugenics with R.A. Fisher as the Galton Professor. But then, in deference to the fact that Carl Pearson's son, Egon, had been teaching in the Department of Applied Statistics for about 11 years by that time, they continued the department as the Department of Statistics with Egon Pearson as a reader. now a reader in English, a reader is something like an associate professor or something like that. Now most departments are headed by a single professor, but Egon became the reader. And KP, he fled. And he fled all the way across the campus to some rooms that were provided for him to use in the zoology department, and Florence Nightingale David was his assistant, and together they edited Biometrica. Jerzy Neyman had been appointed a special lecturer in 1934. He'd been there earlier, but he was now back again, and he'd been a special lecturer in 1934. When I arrived, and the situation maintained itself while I was there was this big schism between the two groups. R.A. Fisher and Carl Pearson's former assistant Julia Bell, Kay Mather, W.L. Stevens, G.M. Morant, they were all up on the top floor, which the British would call the second floor, we'd call it the third. They had electric Monroe calculators, Marchant calculators, and Fisher had a big electric millionaire machine. On the middle floor, which we would call the second, but which in English parlance is the first, was the Pearson group, with Egon Pearson, Jerzy Neyman, and B.L. Welch. And their calculations were done on hand-cranked Brunsvigas. These were things that you pulled down levers like this, and then when you wanted to multiply by 12, you cranked it 2 times and then flipped it over a little bit and cranked it once again. And each time you cranked it, it sounded like it was ripping the guts out of the thing. It made a terrible noise. And I, of course, was viewed as the wealthy American, which I wasn't. I did the whole course over there for 2 years for about $2,000. Dollars were bigger in those days, but I had brought with me an electric Monroe. I had gotten that electric Monroe when I worked with the College Board. They had switched over from electric Monroes to electric Marchants. And I was watching the fellow from the Marchant place one day loading these Monroes in a truck, and I said, "What are you going to do with those?" He said, "Well, I got to turn them over to the company. They'll give me $25 for each of them, and then they'll throw them out." I said, "How about my giving you $25? And he said, "Fine, give me $25. Your $25 is just as good as their $25. So I gave him $25, and he said, "Well, take your pick." And so I took one off the truck, and that was mine. Now, just before I arrived, there had been a big event. Egon Pearson had been appointed professor of statistics. Now, this was just before I arrived in the summer of '35. Now, this was a big event. This was the first time there had been an appointment of a professor of statistics in the United Kingdom that was not under the umbrella of economics. Arthur L. Bowley had been professor of statistics at the University of London from 1915, but he was professor of statistics in the London School of Economics. That there should be no professor of statistics outside of economics was so deeply ingrained in the United Kingdom that when in 1945 David Finney took over to head up a new statistics program at Oxford, they couldn't face it. And instead of calling him professor of statistics, he was appointed lecturer in the design and analysis of scientific experiment. There was a great deal of tension between the Pearson group and the Fisher group. I was told, I wasn't there at the time, that I was told that there had not been much tension. Egon Pearson is a charming fellow and a very fair fellow. He's like Bill Cochran. He's a very fair and very charming fellow. There had been no tension before Neyman presented his path-breaking paper on 2 different aspects of the representative method, at the June 1934 meeting of the Royal Statistical Society, in which today most people say he laid the foundations of modern sampling theory and criticized Fisher's fiducial inference as fallacious, and indicated that his confidence intervals were mathematically sound and led to, not to inductive inference, but to inductive behavior. You'll see that, you can find that down in the main library in the Journal of the Royal Statistical Society, XCV 11, in other words, 97. And Fisher was one of the discussants. And his discussion runs from page 614 to 619, and it is very bitter. It is very bitter. Now, at the same time that Pearson became professor of statistics, Neyman moved up from special lecturer to reader. So he now is sort of an associate professor. And Constant Reed, in her book Neyman from Life, reports a conversation that Fisher had with Neyman at that time. It seems that Fisher was going to the meeting of the university at which they were going to approve these appointments of Pearson to professor and Neyman to reader. And he stopped by to see Neyman on the way. And he said that as I know, this is Neyman talking now, as I know, he had published a book, that's Statistical Methods for Research Workers, and he's upstairs from me, so he knows something about my lectures, that from time to time I mention his ideas, this and that. And that this would be quite appropriate if I were not here in the college, but say in California. But if I'm going to be at University College, then this is not acceptable. And then I said to him, do you mean that if I'm going to be here, that I should just lecture using your book? And he gave an affirmative answer, yes. And I said, sorry, no, I can't promise that. And then he said, well, if so, then from now on I shall oppose you in all of my capacities. And then he enumerated a few, member of the Royal Society and so forth. There were quite a few. Then he left, banged the door. Well, Fisher was overruled, and Egon Pearson got to be professor and Neyman reader. But RAF did succeed in blocking Neyman's appointment to the Royal Society, and also blocking his election to membership in the International Statistical Institute until 1948. Now, one of the things that I discovered when I got there was that I had come into statistics sort of in the middle. I'd had this course with Duncan, and I'd had that economic-like course, but I didn't know a lot of I didn't really know a lot of the Pearsonian and Eulian work. And I discovered this wonderful little book, An Introduction to the Theory of Statistics. And it seemed that all of my fellow students who came from various parts of the British Empire, including India, all these people had grown up on Yule's book, and I'd never even heard of it before. And I found this book fascinating, and I discovered in it a formula that was new to me. It was the formula for the variance of the mean in correlated measurements. The one that has that, in the numerator, it has the factor 1 plus paren n minus 1 close paren r bar, where that is the average correlation between all the measurements. And this was new to me, and it showed that if you have a little correlation, that the standard error of the mean can get big in a hurry. And when I got to the Bureau 10 years later, I found that my physicists here had never heard of that formula either. Now, the courses that I took at University College with Fisher were design of experience, mostly factorial design, but it was his book, and it just come out about that time. And theory of estimation, this was very much along the lines of his 1925 paper, the small one, although he had some of the stuff from his 1922, the great big green one. And the history of biometry. Now that was an interesting course, because in that course he revealed his knowledge of the work of the continental probabilists, and and Gauss and people like that. And a lot of people who complained about Fisher's writings complained that he wrote as if he'd invented everything himself. Well, it became clear he hadn't invented everything himself, but that since he made the excuse that since he was writing for biologists, it wasn't their problem to know where he got it. Their problem was to understand what he wrote and be able to use it. And so he didn't fill up his things that way. I asked him one day, I said, where did that wonderful little formula come from that it's the bottom of the table of Z? That was before we had F. The table of Z that tells you how to calculate the percentage points of Z up in the, down in the lower right-hand corner where both of the degrees of freedom get big. Oh, he said, you know, the distribution of Z is related to the incomplete beta function, and in Laplace's paper of, I don't know what he said, 1785, he gives an asymptotic expansion for that, and said if you just take Laplace's paper and change incomplete beta function first into F and then into Z, you'll get that formula. Well, I went back and looked up that paper, by George, there it was. And so he really knew what was going on in these things. He attended some lectures at Cambridge about 1912 when he was there by the Hungarian Jordan, in which Jordan gave quite a lecture on orthogonal polynomials, and Fisher then adapted them, and a lot of people thought he'd invented them, but including his daughter thought he'd invented them, and I wised her up on that. I don't think she's too pleased with that. Now, the people that came to these lectures, some people came down from Rothamsted, W.G. Cochran, Betty Mitchell, who later became Mrs. Cochran, and a Mrs. Watson from Rothamsted, and J. Oscar Irwin from the London School of Hygiene and Tropical Medicine. The courses that I took with Neyman were advanced probability. He was an intense, I forgot to say, Fisher was a terrible lecturer, was a frightfully bad lecturer. And the lectures often didn't come out the way they were supposed to. He'd go through all this thing on the blackboard, and something was supposed to come out orthogonal to another thing, and it would turn out to be parallel. And he'd say, well, somewhere there's a change in mistaken kind and sign instead of a cosine here somewhere. You'll find it. You find it, you know. And he was a terrible lecturer and boring besides. Now Neyman was an intense lecturer, very intense, he also had a bad habit. Well, what he would do is he'd come over to look over somebody's notebook and say, what did I talk about last time? And you told him what he talked about last time. He'd go to the board and he'd get going. But the notation that he used today might be entirely different from what he did last time. It matter like X might be Y this time and Y might be X, you see. And this was very disconcerting. So I took my notes in a standard Eisenhart notation no matter what notation he used. And but he was a very intense lecturer. And the courses I took with him were transformation of variables, Jacobians, and then characteristic functions, and theorems on expectation. And that's when he championed this so-called Gauss-Markov theorem, which there's still a controversy over as to whether it isn't all Gauss. I think it's all Gauss. Kruskal thinks there's some Markov in there. That was a very, very interesting course, and I learned a lot from there. Now, it's a rather interesting thing that right about this particular time, when I was taking these courses, a professor at, this is 35, a professor at the University of Pennsylvania died suddenly in the fall, about 2 weeks before he was going to give a course down there. And Wilkes was hired to fill in, and he wanted to give a modern course. And so he wrote to me in desperation, I've got to give this course, I need problems for students to solve. And so I would keep sending the problems, every time we got problems to solve there, I'd send them off to Wilkes in Princeton, so that he was fed these problems. Now I also took courses with Egon Pearson, testing statistical hypotheses. That was Neyman-Pearson theory. He was a very clear lecturer. Proofs always came out right. And systems of frequency curves, Graham-Charlier, Edgeworth, and the Pearson system of curves. Now, fellow PhD candidates that were there in residence were P.L. Hsu, 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 P.V. Sukatmi, M.D. McCarthy, and P.C. Tang, and R.W.B. Jackson. Poor old McCarthy. He and his wife knew English. They were from Ireland. But the Irish had started to teach Gaelic, and he said that my wife and I are disenfranchised. When the children want to talk so we don't understand them, they talk Gaelic. Now, professional visitors that we had were George Roche from Denmark. He was up in Fisher territory. And Paul R. Ryder, he was also, as I told you, up in Fisher territory. U.S. Nair, not K.R., but U.S. Nair, and R. Sato from Japan. Now, we had transient visitors. Chester I. Bliss. He was working up with Fisher on the dosage mortality, the drug, what do you call that kind of testing, where the intensity testing, where he wrote a lot of stuff on that. Before he was up there, nice red beard and everything, and he left there to go to the Imperial, not the Imperial, but the Plant Institute in Leningrad. He was very partial toward communism at that time. Two others that were there were W. Edwards and Lola S. Deming. They visited both places, Fisher and the Neyman Pearson group. Ragnar Frisch. He was all keen on confluence analysis at that point, which is a kind of correlation analysis. He later got the Nobel Prize in economics recently, I've forgotten when. H. Fairfield Smith, he was up with Fisher, and he published the first paper, Fisher guided, of course, on the discriminant function. It appeared in the Annals of Eugenics. So I forgot to say that Fisher got the Annals of Eugenics also when the split up came. Stanislaw Krojejczyk. Boy, that's a humdinger of a name to spell. K-O-L-O-D-Z-I-E-J-C-Z-Y-K. I never can do it without looking it up. And then Henry Valensky and Helen Walker from Teachers College in Columbia. Now, one of the sad things about all of us was that none of us ever got to meet Carl Pearson. We all asked to go see him, and Egon Pearson always came back and said, "This is a bad day. Father's very testy today." I learned later that this may have been caused in part by the fact that there had been friction between Carl and his son ever since the son had come back from America in 1931. He had been at Iowa City in 1931, and simultaneously Fisher was at Ames. And Reitz had a sort of a get-together where Snedeker brought Fisher over from Ames, and they had a big powwow there at Iowa City. And in that powwow, Fisher point blank asked Egon Pearson whether the work by Neyman himself, published in 1928 on the testing hypothesis, whether this didn't prove and demonstrate conclusively that he, Fisher, was right in assigning the degrees of freedom to the chi-square tests and that his father was wrong. And apparently, put on the spot, Egon agreed. And word of this got back to England, and I'm told that from that point on, there was tension between the father and the son. But it was a great disappointment to us that we never got there, never got to see him. Now, Valensky was an interesting chap. He was learning English, and he came to me one day and he said, "Excuse, please, Henri Valensky here, Mr. Eisenhart. Excuse, please. I see that you talk a great deal. Excuse, please. I am rooming with R.B.W.B. Jackson. Jackson hardly talk at all. I not learn English. May I have lunch with you, please? And learn English fast. And I said sure. So I had lunch with him quite a lot after that. And one day he was sitting up on the desk or something, and he was reading a book. And he asked me, Eisenhart, what does get rid of mean? And I said, well, suppose you have a dog, and you tell the dog to stay home, and you go down the street and you turn back, there's the dog slinking along. And you tell him to go home again, and you go on down, you turn the corner, go down a ways, and you turn back, here he is coming around the corner. You cannot get rid of that dog. Ah, Valinsky understand. Girl love Valinsky. Valinsky not like girl. Valinsky not get rid of girl. Now the other thing that is interesting in two respects is that when I was at Statistical Research Group in Columbia during the war, W. Allen Wallace held up as an example of superb exposition a paper by Chiborowski and Walensky called Statistical Principles of Routine Work in Testing Clover Seed for Dodder, which was published in Biometrica, volume 27, in October 1935. And I still have a copy of that paper, black and white on black. That's the way you copied things in those days. And Wallace made us all read that paper and get inspiration from it. When Egon Pearson was here a decade or so ago, I mentioned this. And Pearson blushed a little bit and said, when I received that paper from those two chaps in Poland, it was horribly written, so I wrote it over. Well, that was the way it was done in those days. Carl Pearson used to rewrite the papers that people submitted to him. Now, Fisher and Neyman just would snipe at each other. Now, who was the rat that was telling the other what the one was teaching? I don't know. But somewhere in our midst there was a stool pigeon or something of this sort. Because Fisher, of course, would be promoting randomization in his lectures, you see. And the next lecture or so, Neyman would go out of the way of what he was supposed to be teaching to comment on Professor Fisher's randomization. And Neyman would say that randomization just stirs all of the inequalities into the fertility into the field, into the error term. He said if the field has a very uneven fertility, he said you don't get rid of it. He said you just mix it into the random error, it makes the error bigger. And so you have to have a much bigger effect in order to overpower this thing that's gotten the error term. The thing to do is to adjust for it. Adjust for it. And so what he did was he proposed a method of orthogonal polynomials, two-dimensional orthogonal polynomials, where you fit a surface to the field and subtract that out, like you correct for linear regression in things and so forth. Fisher, of course, somebody told Fisher, next lecture, Fisher comes along, he has a case where the fertility isn't smooth, but where the thing is highly disjunct. You know, some of the plots are on the low ground and some are on high ground. Down the low ground, the river makes them very wet, and middle ground they're average, and up here in the dry ground, the plants hardly grow at all because it's so dry. Of course, you shouldn't do analysis of variance there anyway, but Fisher points out that if you were to do this, that Neyman couldn't fit a polynomial to this step function sort of thing, and then Fisher would talk about fact he would never mention these things to worry about, you know, with analysis of variance and so on, and factorial design, and he was gung ho on that, you see, and he never once mentioned about additivity or the magnitude and nature of interactions. You know, he just told it beautiful. You see, you do this thing and you get out all these answers. You see, and so Neyman comes in with a fertilizer problem, where if you put on too much, you get a negative, you get a less effect than if you put it all on. The stuff combines chemically or something, and so that what happens is that if you put on too much of the two things, they combine, and now you're putting essentially sand on the stuff, and then Fisher would complain in the next lecture that Neyman concocts hypothetical crazy experiments, you know. It just went on all the time. It was a pity. Now in our workshop, we had to do statistical analyses of all the Fisherian and Pearsonian kinds in the thing, and one thing that happened there that I used to stress when I talked around the country here on teaching statistics at universities, and that was that if your students if you're going to give a talk somewhere, and if part of your talk has been prepared, the calculations, the graphs or something have been prepared by one of your students, and you're going to give that talk at a place nearby where he or she can witness it, by all means invite them. It'll make them feel good. Now this happened to us in London, and of course it was very handy because University College on Gower Street, and just down Gower Street a little bit further was the London School of Hygiene and Tropical Medicine, and it was in the auditorium, we would call it, the lecture theater they call it, of that institution, that the Royal Statistical Society held their meetings. And so it was just like walking from here to my office, or maybe to the engineer mechanics building to go to these things, and so we would go. And I remember we did some calculations in under Welsh's guidance, and in May 1936, Egon Pearson was the proposer of thanks to a paper by C.E. Gould and W.H. Hampton called Statistical Methods Applied to Manufacture of Spectacle Glasses. And this was quite a detailed, he took these data these people had, and he really gave them the works, and he's subjected to a lot of statistical analyses. And he remarked, and we all got big as balloons, you know, the whole analysis was carried out under the direction of Mr. Welch by students in the Department of Statistics, University College. We were all sitting in the audience, you know, and we just glistened, I'm sure, at this point. We were all so proud of ourselves for having helped with this important contribution. Other RSS lectures that I attended, in March 1936, Cooperation in Large-Scale Experiments, a discussion opened by W.S. Gossett. This was the first talk that student ever gave using his real name. And it's published in the supplement of the JRSS, Volume 3, which you have up in your library, stat library. And Fisher's discussion is in there, and it's very short. Now, student was the one person that Fisher never attacked. Fisher knew that student was responsible for Fisher's contributions. Just like Weldon had asked the questions that Carl Pearson solved, student had asked the questions that Fisher solved, and Fisher knew this. And he even said so in his paper on regression, that student had asked the questions, and he refers to him as student, I guess. And so in this case, he wanted to be sure that he wouldn't get out of hand, and so he read his discussion, but you could see him sort of shivering as he did it, you know. And afterwards, student got up, you know, and he sort of put his hands in his pockets and he smiled and he said, "You know, Professor Fisher and we argue about experiment design. Professor Fisher wants to run a highly precise experiment on a piece of land the size of a postage stamp outside of Rothamsted, and the inferences from this experiment are applicable to that postage stamp. I want to run experiments over all of Ireland and to have the conclusions valid all of Ireland." So we said we have difference in purpose, you see. And he smiled and so forth, and everybody applauded, and I met him, and we became good friends. I used to have lunch with him, have dinner with him after these meetings. Now, another lecture that I attended was by J.O. Irwin on statistical methods applied to biological assay. That was in November. In January 37, some considerations of the variability of cotton cloth by an A.W. Bayes, not the famous Bayes. And then there's a Royal Statistical Society has an industrial research group and a study group. And two papers in the study group were by Cochrane, the statistical analysis of field counts of diseased plants. And Bartlett, in May 36, statistical techniques in certain points of field count. Now, that seemed to me a very strange title, and so this morning I went over to the library to be sure that was it, and it was it. Then I attended a fantastic lecture by the London Mathematical Society on probability. Before mentioning this, I ought to just make one other remark, that in England you have two kinds of mathematics, pure mathematics and applied maths. And they had these at University College, pure maths and applied maths. Never the twain shall meet. I was one of those strange Americans, you know. Americans are queer kind of characters. I attended the seminars of both. This just was not done, you know. This was just not done. You either attended the pure math or you attended the applied math, but never should you attend them both. But I did just anyway. Well, so I went down to the London Math Society to hear this discussion of probability. The first speaker was Sir Arthur Eddington. And I discovered he's a much better man to read than to listen to. He sort of talks to his tie, and you can't hear him very well. And he gave a sort of a physicist's viewpoint of the thing. And then Harold Jeffreys got up, and he gave his type of Bayesian approach to the thing, which I always thought it was sort of lifting yourself by your bootstraps. I mean, he wanted to get the same distribution for the standard deviation estimate calculated from the samples as Fisher, so he has to have a prior. So what he does is he chooses the prior that makes the answer come out that. And well, anyway, Jeffreys got up and started giving this lecture, and the third speaker on the program was R.A. Fisher. Right in the middle of Jeffreys' Bayesian presentation, R.A. Fisher got up and ostentatiously walked out. And when the time came for Fisher's presentation, the chairman said, well, it looks like Professor Fisher has left and isn't coming back. And there was a pause for a while, and then J.B.S. Haldane got up and volunteered to fill in the time, and he said how he, as a geneticist, views probability. J.B.S. Haldane was a fascinating fellow. I was sitting in the library at University College one day, and correction. I came into the library, and he was sitting in the library. And then, as I came in, he got up and said, "Haldane is the name, and what are you doing?" And I said, "Well, I'm a student in Pearson's department." "Fine, sit down. Tell me what you're doing." So I told him what I was doing, and so forth. And then he said, "Let me tell you." He's very excited. "Today in my laboratory, I've made an outstanding result. I've gotten a wonderful result in my laboratory. I must tell you." So he talked to me for about 40 minutes, going a blue streak, genetics that I didn't understand, but he obviously was enthusiastic about this. A few days or a week later, I read with amusement in the London Times. Now, Haldane was an outspoken member of the British Communist Party, and he apparently was the plenary speaker at a meeting of the British Communist Party in Royal Albert Hall a week or so after I had this experience with him. I'd met him in this way. And the London Times says that Haldane got up and they summarized in a matter of 5 minutes or so. He made the following points about the importance of the British Communist Party, and then interrupted himself to say Oh, I must tell you about the laboratory experiment I did recently, which achieved, and kept them pinned to their chairs for 40 minutes while he talked to genetics. I thought that was hilarious. Now, Fisher was a bit of a pest sometimes. One day I was walking down the hall, and I was passing the office of Florence Nightingale David, who had come over to the statistics lab. This was, Carl Pearson died in April 36, and so this was probably in the fall of 36 or so. Florence had moved over to the Pearsons, Aegon Pearson's group. And I was walking by her office, and the transom was open. She presumably was in there. The light was on. And Fisher sees me, and he says, "Oh, Eisenhart, do you know a girl by the name of Florence David?" And I said, "Yes, sir." "Is she any good?" And I said, "Why do you want to know, sir?" "Well, she's asked me for a reprint of my paper on the multiple correlation coefficient, and I don't give my papers to just anybody, you know." Well, I was obviously hard put, because the most that I knew about Florence David was that she had been Carl Pearson's girl Friday, and that would never do to tell Fisher. And then I suddenly remembered that she was, right at that moment, she was busy calculating some tables of Fisher's 1915 distribution of the simple correlation coefficient in samples from populations which are correlated. So I told him this. And apparently it did the trick, because a few days later I saw the reprint on her desk. I mentioned this later to Frank Yates. And Frank Yates says, "By golly," he says, "that's the professor for you. That's the professor for you. He knew you were vulnerable, and he just wanted to have a little fun." Now, as I was saying, that the two groups were different, and they had tea. And what happened was that first the tea room was on the Pearson floor, the middle floor, and at something like 3:30 or so, or maybe it was 4, the Pearson group would go into tea. And we had tea and scones and so forth, and we had India tea. Then after half an hour, we all filed out, and the Fisher group came down, and they went in, and they had tea, and they had China tea. See, it was one day Naaman came to me and said, Churchill, he said, one of our young ladies here is not a very strong student, and it's her turn to give the presentation. We students all had to give presentations for the group next week, and she's a rather weak student, so would you tutor her and rehearse her? So I did. And the time came, and she got up. She was well rehearsed. She knew her subject well. And this guy, Naaman, she could hardly write a thing on the blackboard when he asked her a question. And then she'd go on, and he'd ask her another question. And I finally said, "Professor Naaman, Miss Tanner knows her subject. She has rehearsed it for me. She can present it clearly. Just let her do it. Keep quiet until she finishes." Well, I'm telling you, to tell a continental professor to shut up from a student, you could have cut the air, you see. And later that day I heard a roar going on in Florence Nightingale David's office, where she was crucifying him for that and saying that I was right to tell him to shut up. But, well, the upshot of that was that the next test, although I'm sure I got a lot of the problems right, when the grades were published, I got a 0. So that was that. The research in progress in the Department of Statistics in those days was on power functions, unbiased tests of type A and type A1. It was in 1936, Statistical Research Memoirs, Volume 1 came out. They tried that out on me. Aegon Pearson said that he wanted it to be understandable to somebody who had no more statistical training than I had, so I read every single article and pointed out a few places that were unclear. See, these old Carl Pearsonians, they knew all about the moments of various distributions and so forth, and sometimes a formula that would be a foot long would magically drop down to being a short one, because they were talking about a normal distribution, and there are certain relations between the higher moments of the normal distribution which made the thing shrink down to this, and I didn't know that, and so they would put in an explanation. Shahanawani and I did some calculations for the article that appears in there. The ordinary test of whether of the null hypothesis that sigma squared equals sigma squared 0 against the alternative hypothesis that it does not equal sigma squared 0, the one where you use two equal tails, has the unfortunate feature that the probability of rejection is a minimum at a slight distance from sigma squared 0. In other words, the probability of acceptance is a little bit more for this particular alternative than is for the null hypothesis. And in order to correct that, you have to use unequal tails. And Shahanawani and I did the calculation for that. And later on, other people did more of it and got confidence intervals also that were shortest by doing that. P.C. Tang was working on the power function of the analysis of variance, and Neyman was telling us about confidence intervals in his lectures, and he in his original lectures in his original paper published, I don't remember just when, in Poland, he had and in his lectures there he started out by having an a priori distribution of the parameter. And then you went through all the machinations and got an answer. And the answer didn't depend upon that a priori distribution. And so I said to him, look, since this a priori distribution disappears somehow in the course of the analysis, why put it in there in the first place? Well, he says, that's a good point. And I said, I think I can do it. So then we had a lecture like now, and I got up and I did it, only I didn't. Neyman said, aha, he said, that's in the right direction, but you missed the boat. Let me think about it. A few days later, he came in and said, it can be done, I've done it. And then he went to work, and then he came over here and talked about it at Washington, and then in 1937, his paper on outline of the theory of statistical estimation based on the classical theory of probability came out. He didn't say much at that time about my having done all this, but years later, when he mellowed, he I think gave me more credit than I deserved. Sometime in the early 1937, R.W.B. Jackson and I and some of the other students, we went to the ice hockey game at Wembley Stadium, following the where there was a meeting between the Germans and the British. Apparently, we sat in front of a whole lot of students, school children. Some of them must have had the mumps, because the next thing you know, Jackson came down with the mumps, I came down with the mumps, and this was disastrous for some of us. Poor Jackson had been paying his way through college by acting as a cook somewhere, and of course he couldn't continue to be the cook while he had the mumps. And I was living in rented rooms in a place where students lived, and I couldn't stay there, and so I had to spend some time in the London Fever Hospital. So I wrote my thesis, the power function of the chi-square test to goodness to fit, and a comparison with Neyman's smooth test. I wrote a lot of this in the hospital, Neyman, it was a very worrisome time, because Neyman, by the time I got out of the hospital, he had gone to America, and there was a real big question as to whether he'd be back in time for me to finish up before my time in England ran out. Because he was gone, I derived everything much more fully than was really necessary. And as a matter of fact, there are certain polynomials that came into it that I developed them, and I later turned out that they were kind of the Laguerre polynomials, and that's in connection with the smooth test. If I'd known what they were, I could have just named them and not invented all their properties. And one day when I was doing the factorial moments of the multinomial distribution in the library, J.B.S. Haldane came in and looked over my shoulder and said, "Oh," he said, "I see you've got those nice little numbers too. What are they?" And I said, "Well, they're the differences of powers. They're Stirling's numbers of the second kind, or differences of powers of 0 divided by appropriate factorials." And I drew a little diagram to show how they, if you put 0 squared, 1 squared, 2 squared, then you take the differences this way, how they come down there. "Oh," he said, "that's fascinating. That's absolutely fascinating." And so when his paper came out on the exact moments of the distribution of chi-squared when used a test of goodness of fit, he has a note saying, "My friend Mr. C. Eisenhart has kindly pointed out to me that these coefficients are the differences of powers of 0 divided by appropriate factorials." And that scared the life out of me during the McCarthy era, because I could figure that McCarthy would say if I had been important enough. Fortunately, I was so unimportant I was never called. "Eisenhart, did you ever knowingly help a communist?" "Well, yes, sir." "But," no buts, you see. Well, I might just make a few remarks about some historical events that I was participating in as a bystander. I attended the International Mathematical Congress in Oslo in the summer of 1936, and there I met people like Herman Wold for the first time. I was present for when the death of King George V and the accession of Edward VII. The funeral procession for George V through Hyde Park was the most impressive event I have ever witnessed. I spent the spring vacation of March 36 in Switzerland and was held in Luxembourg by Hitler's troops when they entered the Rhineland, but the French didn't fight, and so eventually we were allowed to go on. I was there for the abdication of Edward VII and the coronation of George VI. That was a nice affair. The English were absolutely unaware of the Edward Mrs. Simpson affair up until it was too late. One day I showed Egon Pearson's secretary a little note in the Evening Standard. "Mrs. Lennox Simpson receives a divorce nolle contendere today from Captain Lennox Simpson." And I showed that to Pearson's secretary, and she said, "Marriage and divorce is a private matter. We do not pay attention to these things in England." I said, "That woman is going to marry the king." At that point, she wanted to wash my mouth out with soap and push me down the stairs. But it worked out, as you know. Well, I guess I better close now, except to say that Cochrane told Perry Wilson from the University of Wisconsin about me and invited me to write a letter to Wisconsin to promote myself for a job they're having there. And to show you what a nice guy Egon Pearson is, Egon Pearson said to me one day, "Apparently Wisconsin is considering you for a job there. I hope that you have made friends with Fisher, because if not, he will probably blackball you." And I said, "Oh yes, I'm friends with Fisher. As a matter of fact, I even wrote a little booklet for him. There were a couple of students in psychology who wanted to use rank normal deviates to analyze some of their data. They didn't know how to do it. Professor Fisher said it wouldn't be proper for me as a professor to sort of write a primer for them. But you're a fellow student, so you write the primer, and then I'll see that it gets smuggled into the University College Library, and the students will find it there, and then they'll use it." And so that's what I did, and so I was on good terms with Fisher too. Well, I think that's more than enough.